Hello, everyone. We will now see a tech demo from Mikel Rodriguez, AI Red Team Lead at Google DeepMind, on how AI models like Gemini are transforming cyber defense operations. Please join me in welcoming Mikel to the stage.
Thank you so much. Hi, everyone. It's a real honor to be here. Excited to share some recent developments and just work that we've been doing overall at the intersection of machine learning and cybersecurity. And just to kind of start things off, if you allow me, I thought it would be useful sometimes to kind of see where we're going. It helps to kind of see where we're coming from, to get a little bit of context of kind of how we found ourselves in the kind of current situation. And then we'll maybe look into the crystal ball a little bit to see things that might be coming. So to maybe take a step back in terms of like kind of where we're going, if you allow me, we have to kind of go back to like the mid 50s. At the time, if you think of all things, model toy trains, it was not something that you got into if you wanted to change the world. It was really this kind of sleepy hobby, people that were, carefully arranging trees and painting, trains. That is until a group of people saw them for what they really are, which is kind of a network. And at the time, there was this group of people that started this kind of tech model railroad club, and they kind of changed the world, really. And what they did was they broke into the mainframes of the university. They soldered, phone lines into these, train systems to be able to independently control them. And where many people saw this kind of sleepy hobby, they saw the potential to really kind of derail the whole system, if you will. Really, this was kind of the beginning of what a lot of us have now looked back at in the early days of cybersecurity. And they had this kind of dictionary where they wrote about all their kind of shenanigans of things they were doing. And this is where the term hacking comes from, right? So little did they know, but they kind of spawned this whole kind of era of thinking about security of some of these systems. Uh, if you think about kind of going back to that kind of mid 50s, what happened after then was that years went by, and what happened was a lot of this kind of mindset found itself into the personal computer, and there, kind of these early hackers found what they knew best, which is again kind of this idea of networks. And you know, uh, at the time, what was happening was that we went from kind of early days not really relying on computers for much, but then we found that we were increasingly reliant on these networks, whether it was banking, transportation, agriculture, governments. And suddenly it was not the kind of the stakes were much higher. It wasn't just no longer about derailing these toy trains. Now this was kind of part of a fabric of our lives, and the stakes were much higher. And what ended up happening is that, a number of people use those kind of knowledge for beneficial purposes, but a lot of what we ended up seeing was, people using it for financial gain, organized crime using it. We saw then people going after individual citizens, who are now dependent on this technology for their daily lives. And this is not something that, if you like fast forward to today, um, even organizations that are heavily defended can be victims of these type of attacks, right? I'll pick on something that we saw at Google about now at this point like 10 years ago, which started with someone just clicking on an innocent link. And if you think about it, any day there's something like 50 million links that people are clicking on, but this particular link had sent the person to a website that then installed malicious software on the individual employee's computer. And that was the beginning. It just took just kind of one entry point, and suddenly this organization had a foothold on pretty much all of Google. And this was just kind of an indication of, even when you have a highly resourced organization, this sort of thing can happen. And back in the day, what we did was we took a look at this particular attack, and when you look at it, it was just a bunch of zeros and ones, kind of mumbo jumbo to most people. But what kind of jumped out pretty quickly, if you look at within the kind of buried text, was this kind of word Aurora. And for those of you who are kind of have your history better than I do, The Aurora has a specific meaning, and it actually goes back to the name of a ship that fired kind of the first shot in what was the Russian Revolution. So it kind of gave an indication of where this attack was coming from an APT perspective. So this is kind of an indication in the sense that we're coming from this early days of, just people kind of hacking model sold trains to now being able to have a foothold within a single kind of click of a link that might seem innocent. Uh, so what we found was that many times when you're kind of victim of one of these attacks, it almost feels like you're playing this game of chess, right? Where if your adversary knows your moves, they could counter your moves and be one step ahead of you. So this kind of got us thinking. At DeepMind, we do a lot of work in the area of thinking about solving strategic games. Um, so we've done this for a number of years, right? So we started out with very simple games, things like trying to solve, Atari games by just looking at the pixels of a computer and trying to get it to understand the strategy of the game and essentially find optimal strategies to solve it. Here you're seeing kind of a simple solution to this Atari game where it figured out if it sends the little ball over the top and it kind of starts digging around, it's one of the optimal strategies to solve that. Uh, but then we kind of started looking at kind of increasingly high stakes and more complicated games, things like the game of Go, right? So this is an incredibly complicated game that has a vast search space. And a number of years ago, there was kind of a pivotal moment when we were able to apply some of these machine learning techniques, specifically in the area of reinforcement learning, to solve this game to the point where we were able to beat world champions in this space. So you could think of kind of what we've been doing is this kind of ladder, this rung ladder of increasingly high stakes and complicated games to help us solve this problem of intelligence, which then the idea would be that we could port that over to other domains and problems. So we continued this journey, and more recently, what we started looking at are games where you have imperfect information, where you have kind of the fog of war. You don't know everything. It's not laid before you, kind of like in a game of Go, where you see every piece. You might even have deception, where someone is trying to fool you. So these type of games are a little bit more representative of what we see kind of in the cybersecurity space, where you have imperfect information, you have an adversary that might even be trying to deceive you. So this is kind of where it gets us to thinking about, are these techniques potentially useful in some of these domains? And we've started to see that in other areas. So for example, we're not just about trying to solve these like, video games and board games. Just to give you an indication, a lot of these techniques then transfer and can make significant breakthroughs in some of these other areas. An example is in trying to prove age-old math theorems that were basically unsolvable for sitting there for decades. We're now able to tackle using some of these machine learning approaches. Protein folding, that has come a tremendous long way now that we've been able to take some of those general purpose approaches that we were solving in these kind of game environments and port them now into areas of biology. So it's been really exciting, this kind of moving from solving increasingly complicated intelligence tasks and then seeing what it unlocks for us. So one of the things that we've been kind of interested in is we've seen tremendous breakthroughs in biology, mathematics, and we're curious about what it could do for cybersecurity. And cyber has some very unique challenges. And I kind of want to walk you through some ideas that we have and things that we're excited about. So to do that, I have to kind of maybe take a little bit of a detour. The work in cyber started, of all places, we were looking at ancient Egyptian texts, which sounds completely disconnected. But we were looking at using AI to decipher old ancient texts and translate them. And we were using combinations of computer vision and transformer models to basically encode this information which had been lost to humanity and see if we could translate it. And a number of us on the team thought, wait a minute, do you think this could maybe be useful in other domains, maybe even the cyber domain? So this idea of taking powerful models that are able to encode information from one kind of cryptic domain, make sense of it, is something that we've started to play with in the area of cybersecurity. Early days, we started doing very simple things. we started thinking about, can we apply these same techniques to help us classify if a bit of a code in a large code base contains some kind of vulnerability. So we began with some of these early transformer-like models, and it turned out to be very promising. We then kind of evolved that to what now is called alpha code, and what that allowed us to do was take uh, large amounts of data having to do with vulnerabilities that we've seen over decades. Google has this incredible project called Project Zero, which is looking to kind of eradicate zero-day vulnerabilities. So we have, these world-class kind of ethical hackers that understand OffSec. We have, decades of cybersecurity vulnerabilities. And the idea was, can we start kind of imbuing these models with the ability to highlight if a bit of code has a vulnerability? And it turns out that it's still early days, but what I can tell you is that it's looking incredibly promising. And I'm to the point where I'm beginning to feel like the age of like human kind of introduced bugs in code might be something that we might look back at as a bit archaic, in the sense that we have these machines that are trained with decades of cyber data that help us illuminate some of the common vulnerabilities that we've seen over the years. Uh, Now I wanted to just peek a little bit into kind of the future of kind of where we're heading with some of this stuff. We talked a little bit about kind of where we're coming from, early days where the stakes were lower, kind of just it was kind of a innocent time where we had people kind of playing around with hacks, and then we saw it evolve into a kind of higher stakes situation as we increasingly depended on some of this technology. But I wanted to give you a sense, a little bit of a kind of what we're working on right now. So a lot of what we're doing is taking an approach to increasingly agentic AI. And what that means is systems that are able to decompose much larger problems into subtasks, plan much longer in the future, instead of just give you an immediate reaction or a response. Sometimes they need to take a time and actually decompose the problem into a series of subtasks. And more importantly, they have access to tools, right? So instead of just being a chatbot that you engage with, they have access to what we would call like software 1.0 tools. That's everything from code interpreters, fuzzers. They have access to a kind of knowledge bases of other vulnerabilities that we've seen in the past. And we really are genuinely excited about where that's going to take us. So one of the things I want to show you is an agent that we've built that has access to kind of a lot of the CVEs, the common vulnerabilities and exposures that have been known over the years. And it basically is acting as an assistant that helps us explore, in this case, the MITRE attack framework, and tries to understand, given a system, it essentially tries to hack it using known TTPs from real world adversaries in order for us to secure it. And what you're seeing over here is kind of an early prototype and demo of this. This is a system that's able to go off on the web, research vulnerabilities, deploy them against the system in order for us to discover proactively these vulnerabilities and patch them. So it's able to do things like fuzzing, it's able to deploy known exploits. And in this case, it's solving kind of what it's called a capture the flag exercise. And we're really optimistic. So far, it looks like these systems are incredibly capable at some of these baseline tasks. One of the ones that I'm particularly excited about is this idea of using reinforcement learning for fuzzing. So for those of you who are not familiar, fuzzing is where we have a bit of a program, and we really, these days, where we essentially throw a lot of noise at it to try to discover vulnerabilities and weaknesses. But what we're finding is that these assistants are able to intelligently traverse the right areas in memory to understand where is it likely to have a vulnerability, and are a much more effective way of discovering these. Great. So if you fast forward to today, what we find ourselves is that internally we have teams that are focused on offensive security. And what we're seeing it is much more as a human machine collaboration. Kind of the days of having kind of these artisanal attacks or experts that are really focused on particular bits of code are hard to maintain. So what we're really doing is kind of imbuing a lot of this process with increasingly using machine learning as an assistant. Um, and we're not alone. There's an entire DARPA grand challenge focused on these sort of things. I'm very optimistic about the country in general kind of investing heavily in this area. And so we're really excited about this. I guess the last thing I'll say is that that the stakes have gotten really high. This is something that is not hypothetical. There's a significant financial loss that happens every year because of some of these cyber attacks. We're seeing number of vulnerabilities discovered every year increasing. So we're really excited about this future where you have kind of very powerful cyber assistants to help us proactively explore this space. And I think it's just the beginning, and I just can't wait to see what the next couple of years look like. Last thing I'll say is that it's early days. It's an amazing time to get involved. If you're interested in learning more, please reach out. Always happy to collaborate. And with that, I'll thank you.
That's it.